Hello friends, welcome to lecture number 8 of Fourier series. In the previous class, in the previous lecture, we have discussed, I have shown how to prove this Parseval's formula, and here we're gonna apply this formula to solve these two questions. First note these two questions, and then we're gonna solve these two. So before we solve these two problems, please watch the last lectures. Links of the previous lectures are given in the description box, so you may go through if you want. And if you are new to my channel, please subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded, and also share with your friends. Please help me to grow my channel. Okay, so now let's start. So this is the first question we're going to solve here. So now here you see what we have to do here. We need to use the sine series for this function, which is equal to 1 when x is greater than 0 less than pi. And from this we have to show that pi square by 8 is equal to 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square, and so on. So I forgot to give this one dot dot dot. Okay, so these things should be proved here. So first let me write the given function here. This is the interval is 0 to pi. So now sine series is f of x is equal to summation bn sine nx. This is our sine series. And how to obtain the bn, we have already discussed these kind of things, and half range series, when we have discussed half range series and all those. So what's all the previous lectures. Okay, so bn is equal to 2 by pi 0 to pi f of x sine nx dx. That is what we have got. How to find bn, right? So here you see 2 by pi 0 to pi, and in this case f of x is your 1, right? Your f of x is 1, so we're gonna put here 1 instead of f of x, and then sine nx dx. Sorry, I forgot the n. Sine nx dx, right? This is what we have got. Now if you integrate sine nx, then what are you gonna get? So let me write here 2 by pi, so minus cos nx by n, integrating sine nx, we have got this, and limit is 0 to pi, right? So now let's put the upper and lower limit. Then what we're gonna get? So let me show you here. Minus 2 n pi. If you put the upper limit, then you're gonna get cos n pi, and putting the lower limit, you're gonna get here minus 1. And here you see this n is taken outside here, right? So this is n pi. Now you see value of cos n pi. The value of cos n pi is given by minus 1 to the power n. So it's gonna be plus 1 when it is even. When n is odd, then this is gonna be minus 1. So that is the value of cos n pi. So we get bn is equal to minus 2 by n pi, here minus 1 whole to the power n minus 1, right? So and this gonna be equal to, if the value of n is even, if n is even, then what you will get? Then this minus 1 to the power n, that's going to be 1 plus 1, right? For n is even, then here we have minus 1. So let me go to the next slide, then it will it will more clear to you. So let me take this step, let me solve this step in the next slide. So let me copy this and let me go to the next slide here. So here you can see, as we have minus 1 and minus 1 to the power n, and here 1. So if n is even, then minus 1 to the power n, that's going to be equal to 1 plus 1. And if you put plus 1 here, plus 1 minus 1, that's going to be 0. So then in that case your value of bn, that's going to be 0. And if n is odd, then the value of n minus n to the minus 1 to the power n, that's going to be minus 1. And in that case minus 1 minus 1, that's going to be minus 2, and minus 2 into minus 2, that's going to be plus 4. So then we will get bn is equal to 4 by n pi, right? So that's what we will get, right? Okay, so hope you have understood this, right? So now the sine series is gonna be, therefore the sine series is, so we know that sine series is given by this. So we have that f of x is equal to 1 for x greater than 0 and less than pi. That's why we're going to put here 1, and here we're going to put the value of b and what we have got. Okay, so we're going to get 1 is equal to value of b in bn is 4 by n pi. So we will get 4 by summation, just wait, summation from n is equal to 1 to n, 4 by n pi. And here is the Parseval's formula for half range sine series. We have discussed in the last class already, but I made a mistake in that in the last lecture. So I have made the correction. I have mentioned about that on the thumbnail. You can see the thumbnail of the last lecture. I made the correction here. What was the mistake I did? I made there was this. Actually, I have written this. This one is equal to this. I have written this. So this is not correct. This term should not be there. Okay. So a naught square by 2 should not be there. Okay. So hope you have understood. Now let's proceed. Okay. So here you see our range is 0 to pi and not to c. So that's why we're gonna replace this c by pi. Okay, this c gonna be replaced by pi. So let's go to the next slide. Now what we're gonna do here. So here you see, let us replace the c by pi. Okay. So then what we're gonna get? Therefore 0 to pi f of x whole square dx is equal to pi by 2 summation n is equal to 1 to infinity, and value of bn we have got this 4n pi square. That's what we have got, right? So now we have also got that value of f of x is 1. F of x is equal to 1 for x greater than 0 less than pi. So that's why we're going to put here 1. So that's going to give you 1 dx, right? 1 dx, and here pi by 2. So if you put 1 2 consecutively, then what you will get? You're going to get this series that putting 1 you will get 4 by pi square, then putting 2 you will get 4 by, so here we cannot put even number because for n is equal to even. If n is even, then we have got bn is equal to 0, right? So we're gonna put odd numbers only. Yeah, so we're gonna put odd numbers only. So that's why 3 pi whole square, and similarly we can put again 5, right, plus 4 by 5 pi whole square. That's how we're gonna complete this, right? Okay, so now integration of dx is x. So here we're gonna write x 0 to pi, and from here what we can do, we can take 16 pi square common from each term. From each term we can take 16 4 square is 16, so we can take, that means 4 by pi whole square we can take common. So 4 square is 16, then we will get pi square here. so taking common, then here we're gonna get 1, then here we're gonna get 4 is taken common, pi is taken common, 1 by 9, that means 1 by 3 square, then so 1 by 5 square, then 1 by 7 square, and so on, right, plus dot 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 dot, right. So that's what we're gonna get. And after cancelling this pi with pi square, we get pi here below, then this is gonna be 8, right, 8 by pi. So 8 by pi we have got. On this side we will get pi only, pi minus 0. So let me take this last step to the next slide. Okay, let me copy this one first and let me go to the next slide. This is a new slide. Here is the last step we have got. So putting the upper and lower limits, we will get pi minus 0 here, 8 by pi, 8 by pi, and 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus dot dot dot, so on. And so if you multiply this one, or if you multiply both sides by pi by 8, then you're gonna get pi square by 8. Then on this side, pi by 8 by pi will cancel by pi by 8, right? If we have multiplied pi by 8 on both sides, then 8 by pi, pi by 8, that's gonna cancel, right? So hope you have understood this. So on the right hand side we have this result, sorry, 1 by 7 square, and so on. So that's how we can prove. So hope you have understood this. Now let's move on to the next question. One more thing before going to next question. So here you see this should be infinity, not n. Okay, this should be infinity. Okay, so this is our next question. Here we need to prove this. Also we have to deduce this relation. So here you see this series consists only cos, so we're gonna take the half range cos series. Okay, so half range cosine series. So here you see we have the function, this is our function, right, and half range cosine series is given by this, and here in this case c will be pi, right? So because our interval is 0 to pi in this case. So now let's proceed. First let us find a naught. Hope you know how to find a naught. So a naught will be given by 2 by c, that means in this case 2 by pi, 0 to c means 0 to pi. Here f of x, that is x into pi minus x dx. So if you integrate this, then what are you gonna get? You're gonna get 2 by pi and x pi x square by 2 minus x cube by 3, and interval is 0 to pi. Putting the upper and lower limits, what are we gonna get? 2 by pi cube by 2 minus pi cube by 3, then it gonna imply that pi square by 3. That's what we're gonna get. Okay, so pi square by 3. After simplification we have got a naught. Now let's find an. So how to find the an, you know that as well. So we have already discussed these things. An is given by 2 by c, here in this case pi, 0 to pi, right, and the function is x into pi minus x and cos n x dx, right? That's what we get. Okay, so now here you see 2 by pi. If you integrate this, then using the integrating by parts rule, I'm not gonna explain each and every part, because I have explained many times how to use that integrating by parts. Okay, so just multiply these two and take this one as a u and this one as v, right? So then apply this rule, u v dx. Okay, so that is how to apply u, integration of v minus integration of ddx of u, then integration of v, then dx. That's what you need to do. Okay, apply that one, then you're gonna get this result, pi x minus x square sine nx by n minus pi minus twice x minus cos nx by n square plus minus 2 minus sine nx by n cube 0 to pi. Okay, that's what you will get. Or you can apply this rule as well. This one, integration uv is equal to u v1 minus u dash v2 plus u double dash, same thing actually, v3, alternatively positive negative, v4 and plus so on. Okay, so here it is u, then v1 is integration of v, right, and u dash is ddx of u, then v2 is integration of v2, or v2 is integration of v1, right? That's what it means. Okay, if you apply that, then you will get this result. Okay, so then here you see now this term consisting sine gonna be 0, because sine n pi is 0 and sine 0 is also 0. That's why this is gonna be 0 for both upper and lower limits. Now let's come to this second part. Then what we will get here, so 2 by pi, the first part becomes 0, then we're gonna get pi minus n 1 n square, sorry, minus 1 whole to the power n by n square, then plus again 0, this term gonna be again 0, right, then minus pi n square. That's what we will get on putting 0, right? So hope you have understood this. So this gonna imply that an is equal to, you will get minus 4 by pi. If you simplify this, if n is even, okay, if n is even, so minus pi by n square minus pi by n square, there will be minus 2 pi by n square, and here outside we have 2 by pi as well. So this pi is gonna be cancelled, and here you see pi gonna be cancelled, then 2 to the minus 2 plus 2, that's gonna be minus 4 here. Sorry, I made a mistake here, that's gonna be n square, not pi, that should be n square. Okay, when it will be n square? If n is even. Okay, if n is even, right, if n is even. So what if n is odd? Then if n is odd, this term gonna be negative, right? Then what you will get, then you're gonna get minus pi by n square, again minus 1, and which makes this term positive, right? This term is positive, then we have minus pi by n square, and these two cancels, becomes 0. 0 into anything is gonna be 0, that's gonna be 0, right? So, and an is equal to 0 if n is equal to, n is odd, if n is odd. That's what we have. Hope you have understood this. Now let me go to the next slide. Okay, let me copy these results. What is the let me take the value of an, and value of n, we have got this, and also let me take the value of a naught as well. So value of a naught is this one, right? Let me copy this one as well. So this is the value of a naught. So we have got a naught, an, right? So what was the series? Half range cosine series. So here is the half range cosine series, right? So putting those values here, so let me take that. So this is the half range cosine series. So here this c, here you can see this c gonna be pi in this case, then pi gonna be cancelled. So this term can be written as cos nx. Simply we can write cos nx, right? So now if you put those values an and a naught and an, then what you will get? Then you will get f of x. In this case, f of x, our function is x into pi minus x. That's what we have got. And a naught by 2. A naught is minus 4 by pi square by 3, so it's gonna be pi square by 6. If you put the value of a naught here, then minus, you can take the minus 4 common, right? So then you will get, putting n is equal to 1 2 3 up to infinity, we're gonna get this series cos twice x plus 2 square plus cos 4x by 4 square, okay, and so on, dot 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 up to infinity. So this first thing is proved. Here you see this is the question, this part is proved. Now we have to deduce this. To deduce this part, we have to use the Parseval theorem. This is the Parseval theorem for cosine series, half range cosine series, right? This is the Parseval theorem. So here, if we put the values of an, a naught, and function f of x, let me write those values here. If we put these values, in this equation, and here f of x is x into pi minus x, right? F of x, the given function is pi minus x into pi minus x, right? So this is the function we're going to put here, and we're going to use these values. So here an is equal to 0 for n is equal to odd, so that's why we're going to put here only even values of n, right? And here this is the a naught, and our interval is 0 to pi. Here our interval is 0 to pi, so c going to be replaced by pi, okay? Then what we're going to get, using all these values here, so we are going to get this result, right? So now let me go to the new slide. So this is the last step we have got, and here you can see from this term we have got this, and if you expand this, you're gonna get this result, because you can see here, first, as I have already told you, this is nothing but value of an, right? This is an square, and an is we have already got an is 0 for n is odd, so, and value of an is minus 4 by n square, for n is even, so we're gonna put only even values of n here. So that's why, let me show you how to expand this. So if you expand it, then what you will get, minus 4 square, and putting if first even value, that is 2 square, square, then there is a whole square, so it's gonna be 2 to the power 4, then plus minus 4 square by 4 to the power 4, next even value, then minus 4 square by 6 to the power 4, then so on. We don't go so on. So then we have taken minus 4 square common. Minus 4 square is nothing but 16, so we have taken minus 4 square common, and within bracket left these things, right? So hope you have understood this. And on the left hand side, we have expand this, we have multiplied these two, and we have expand using a minus b whole square formula. Then we have got this, then these terms within bracket are integrated. We have got the integration of this, this is the result of this integral, right? And then put the upper and lower limits, so you will get this value, okay? If you put pi here, and here, then you will get these three values. Then you have to multiply this one with these three terms, each and every term. Then you're gonna have, let me show you in the next slide. Then you're gonna have, so after multiplication of this one with these three terms, you're gonna have these values, okay? So then further simplification, we have got this, and finally we have got this. Now 4 can cancel 15 times, and the result is now the result is pi to the power 4 by 15 is equal to this, okay? These things only we need to show, and this can be written in this form. On the here you see this right hand side, this part can be written this way. So what we have on the right hand side, pi to the power 4 by 18 and plus 16, and this can be written as 1 by, so here you see one more thing, just let me do one more simplification here. From this part we can take 1 by as 1 by 2 to the power 4 also common. Okay, we can take 1 by 2 to the power 4 also common. Then what you will get? So let me show you. If you take 1 by 2 to the power 4 common, so taking 1 by 2 to the power 4 common, 2 to the power 4, if you take 2 to the power 4 common, then here this term here it will be 1, and from here we can write 1 by 2 to the 4 to the power 4 means we can write 2 to the power 4 into 2 to the power 4, right? That is 4 to the power 4. So 1 by 2 to the power 4 is taken common, 1 by 2 to the power 4 left, right? 1 by 2 to the power 4 left. And then from here so you can see that 1 by 6 to the power 4, it can be written as 1 by 2 to the power 4 into 3 to the power 4. So 1 by 2 to the power 4 is taken common, so 1 by 3 to the power 4 left, and so on. We're gonna get this, right? So then what we will get on this side here, what we will get, now you see, let me write it again. Then you can see clearly that 16 and 1 by 2 to the power 4, 2 to the power 4 is nothing but 16, so these two gonna we cancel, so we're gonna get only this result, 1 plus 1 by 2 to the power 4. So 1 can be written as 1 by 1 to the power 4, then 1 by 3 to the power 4, and 1 by 4 to the power 4, and so on, right? So these things can be written in the form of summation. So if we do so, then what we will get, pi to the power 4 by 18 plus summation from n is equal to 1 to infinity 1 by n to the power 4, right? So this is the result, that is. So now let me copy this and let me go to the next step. So here I have copied this step, and let me go to the new slide. Here you see this is the last step we have got in the previous slide. So now if you simplify this, bring this term to this side and take LCM, and or after doing so, after simplification, we have got this step, right? So this is what we need to deduce, right? This is what we need to deduce. If you go back to the question, here you can see that this is the question. Sorry. So here is the question, deduce this, right? So this is what we need to deduce. So hope you have understood. If you like my videos, please hit the thumbs up button and also share with your friends. And if you are new to my channel, please subscribe the channel and hit the bell icon as well, so that you get notified when new video will be uploaded. Okay, and when the next part will be uploaded, then it's gonna appear at the end of this video, okay, at the end screen. So if not uploaded, it's not gonna appear, but when it will be uploaded, then definitely that's gonna appear at the end screen. So see you in the next video. Thank you for watching. Bye.